8 months after the Space Telescope CHEOPS started its journey into space, the first scientific publication using data from CHEOPS has been issued. CHEOPS is the first ESA mission dedicated to characterizing known exoplanets. Exoplanets, i.e. planets outside the Solar System, were first found in 1995 by two Swiss astronomers, Michel and Didier Queloz, who were last year awarded the Nobel Prize for this discovery. CHEOPS was developed as part of a partnership between ESA and Switzerland. Under the leadership of the University of Bern and ESA, a consortium of more than 100 scientists and engineers from 11 European states was involved in constructing the satellite over 5 years. The Science Operations Center of CHEOPS is located at the observatory of the University of Geneva. Using data from CHEOPS, scientists have recently carried out a detailed study of the exoplanet WASP 189b. The results have just been accepted for publication in the journal Astronomy Astrophysics. Willy Benz, professor of astrophysics at the University of Bern and head of the CHEOPS consortium, was delighted about the findings. These observations demonstrate that CHEOPS fully meets the high expectations regarding its performance. One of the most extreme planets in the universe, WASP 189b. The WASP 189 system is 322 light-years away and located in the constellation Libra, the weighing scales, explains Monika Lendl, lead author of the study from the University of Geneva, and member of the National Centre of Competence in Research Planets. WASP 189b is especially interesting because it is a gas giant that orbits very close to its host star. It takes less than 3 days for it to circle its star, and it is 20 times closer to it than Earth is to the Sun. Monika Lendl describes the planet, which is more than 1.5 times as large as Jupiter, the largest planet of the Solar System. Based on the observations using CHEOPS, we estimate the temperature of WASP 189b to be 200 degrees Celsius. Planets like WASP 189b are called ultra-hot Jupiters. Iron melts at such a high temperature, and even becomes gaseous. This object is one of the most extreme planets we know so far, says Lendl. For this, CHEOPS uses highly precise brightness measurements. When a planet passes in front of its star as seen from Earth, the star seems fainter for a short time. This phenomenon is called a transit. We have observed several such occultations of WASP 189b with CHEOPS, says Lendl. It appears that the planet does not reflect a lot of starlight. Instead, most of the starlight gets absorbed by the planet, heating it up and making it shine. The researchers believe that the planet is not very reflective because there are no clouds present on its dayside. This is not surprising, as theoretical models tell us that clouds cannot form at such. This happens when the star possesses brighter and darker zones on its surface, adds Willy Benz. Thanks to CHEOPS data, we can conclude that the star itself rotates so quickly that its shape is no longer spherical, but ellipsoidal. The star is being pulled outwards at its equator. Continues Benz. The star around which WASP 189b orbits is very different from the Sun. Because it is so hot, the star appears blue and not yellow-white like the Sun. Willy Benz adds, only a handful of planets are known to orbit such hot stars, and this system is the brightest by far. As a consequence, it forms a benchmark for further studies. In conclusion, Willy Benz explains, we are expecting further spectacular findings on exoplanets thanks to observations with CHEOPS. The next papers are already in preparation. Story source: materials provided by University of Bern. Note: content may be edited for style and length. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.